All right, Math 2, we are doing section 5.3 on page 280. What we're going to try to do this time is kind of the converse of what we did in the last section. This time I'm given a quadrilateral and I want to prove that it's a parallelogram. So all I see is a four-sided shape that I don't really know what it is. I need to prove that this four-sided shape is actually a parallelogram. And if it is a parallelogram, then everything I learned last section is going to be true. All right. So we have a few properties or a few ways to do it. So if both pair of opposite sides of the quadrilateral are congruent, then it must be a parallelogram. So if this was labeled as 12 and 12, 7 and 7, therefore it would be a parallelogram. All right, I come up here. These are going to seem very similar to what we did last chapter. It's just last section. Like I said, it's just the converse. All right, so what it says here is, if an angle in the quadrilateral is supplementary to both of its consecutives, then it's a parallelogram. So what it's saying is, if I know this right here is 100 up at B, and its consecutives, it has two consecutives, A and C, and if this is supplementary and this is supplementary, then I know for a fact this has to be a parallelogram. If both pair of opposite angles of a quadrilateral are congruent, then it is a quadrilateral. So if B and D are the same and A and C are the same, then I know it must be a parallelogram. Okay, so you're going to treat it very similar to the last section. So you're going to look down here and it asks you for what values of X and Y can we do to make it a parallelogram. All right, well, I can either make these angles supplementary, or I can do opposite angles congruent. Those are the only two I have with angles. So since this has an X in it and this has a Y, this has an X and this has a Y, what I'm going to do is match up. Well, I guess we could, well, I don't know. I don't know what way would be easiest. Just for a little bit of algebra in here, let's just set opposite angles equal to each other. Okay, so if 3y minus 2 equals 12x plus 7, and 4x plus 13 would have to equal y plus 10, then I know it would be a parallelogram. All right, so again, two variables, two equations. I'm going to subtract the 10 over here, so I'm going to get y is equal to 4x, and if I subtract 10 from 13, I get a positive 3. I'm trying to get y alone, so I can now take this and put it into this equation in place of that y. So I'm going to say 3 times 4x plus 3, put it in place of that y, minus 2 is equal to 12x plus 7. Distribute across, so I get 12x. This is going to give me a positive 9 when I distribute. Minus 2 is a positive 7. That didn't get me anywhere, did it? All right, so since that did not work when you set them equal to each other, what you have to do then is go to our consecutive. All right, so I know that E and H are going to have to add together to get 180. So 4y minus, that's going to end up being a positive. I'm adding them together. 3y plus 1y is 4y. Negative 2 and 10 is an 8. They have to add together to get 180, so I can subtract that. It gives me 172. Divide, that's going to go in there, that 4, 12, 43 times. All right, and then I'm going to do the same thing with this one. I'm going to say that 16x, I'm adding them together, plus 20 has to add together to get 180. So I know 16x has to equal 160, divide by 16, and I get x to be 10, x and y to be 43. There are the two answers. Okay. I would probably go the same route here. Well, actually, in this one, I would probably set these two equal to each other and solve, and these two equal to each other and solve. Those are the opposite angles. Again, I can try it this way. I don't know if we'll run into the same problem we did in the previous one. And here, we're going to set opposite sides here equal to each other, which is curious why. Anyway. All right, here's the next theorem. It says on here, if the diagonals bisect each other, then it's going to be a parallelogram. Okay, and then on page 283, if one pair of opposite sides are both congruent and parallel, so one pair has to have both things happening, then it's going to be a quadrilateral or a parallelogram. All right, so like if I take a look here and there ask you, is this a parallelogram right now? It is not. You have one pair of sides that are congruent, you need both, and I have one pair of sides that are parallel, and again, I would need both, or I could do the same pair as both parallel and congruent. So in this case, neither one, but I could work myself through and figure it out. But as of right now, just staring at that, I would say no, it is not a parallelogram. All right, so it says, can you prove this quadrilateral is a parallelogram? Does it fit one of our reasons? And this is a yes, because opposite angles are, and it has to be both. Both pair of opposite angles are congruent, so yes. This is a no. One of the diagonals is being bisected, but I don't know anything about this one, so I would have to say no, this is not a parallelogram. Okay, if you look over on page the bottom of page 285, it goes through all the methods, everything that has to happen in order to be a parallelogram. Okay, so if one of those things is occurring, then you can say yes, it is a parallelogram. All right, so if I come over here, I'm at the top of page 286 on Do You Know How? This is the one dealing with consecutive angles. If this angle is supplementary to its two consecutives, then it would be a parallelogram. So I would just subtract 180 minus 68 to get my y, then it would have to be a parallelogram. All right, is the given information enough to prove this is a parallelogram? Okay, 2y, 2y, x and x. So does that fit one of the reasons over here? And if I look, it's fitting this reason right here where opposite angles are congruent. I had a 2y and a 2y and an x and an x, so yes, it is. All right, is this one proving? It looks like I have a diagonal, but are these the same and are these the same? No, they are not, so that does not prove it is a parallelogram. All right, your homework is going to be over here on page 287 and 288. We're going to be doing 12, 13, and then 17 through 20. All right, 13 is a proof. It's walking you through it, so you just need to fill it out. Now, 12. What you need to do is turn these into a biconditional. If you remember a biconditional, you take its statement and its converse and you rewrite it with an if and only if in the middle. So if you look at some of these theorems, okay, so let's look at theorem 40. All right, I need to flip all the way back. Theorem 40 is on page 270, and it says, if a quadrilateral is a parallelogram, then opposite sides are congruent. All right, well, its converse was in this section. Okay. And it was theorem 45 right here, which says if both pair of opposite sides of quadrilateral are congruent, then it's a parallelogram. So what you would do is take these two theorems right here, all right, and what you want to do is to turn them into a biconditional. So I would say, remember, you don't start with an if. You would say a quadrilateral is a parallelogram if and only if its opposite sides are congruent. So what I did was start here with theorem 40, and I just took out the if, and I said a quadrilateral is a parallelogram if and only if its opposite sides are congruent. And that takes into account theorem 40 and theorem 45 all as one. And you need to do that with all of those. All right, let me know if you have any questions.